Assalamualaikum warahmatullahi wabarakatuh. Hi everyone. Today we are going to continue lecture 4 of 5 for topic 9 differentiation. For this lecture, we are going to discuss subtopic 9.4 implicit differentiation. The objective for this lesson, for this lecture, is to find first and second derivative implicitly. From previous lesson, we have learned differentiation, which is, let's say we have a function y is equal to fx. For example, we have y equals to 2x plus 1. And then we are going to differentiate y equals to 2x plus 1. We get dy dx equals to 2. So as you can see here, y is equal to 2x plus 1, we can differentiate and directly we get dy dx. So for this case, y is equal to 2x plus 1 is called as explicit function, since we have y as a subject. Alright, so for example, the function y equals to sec x squared minus 25. This is also explicit form. Y is equal to x minus 1 over x plus 3 squared. This is also called as explicit function. Okay, what is implicit function? For example, the function y plus 2xy minus y squared equals to 3. So this is called as implicit function. For this case, kalau nak kenal implicit function, it cannot be written in the form y is equal to fx and y equals to fx is implied by the function y plus 2xy minus y squared equals to 3. So if the function cannot be written in the form y equals to fx, so then it called as implicit function. So we differentiate implicit function, we get implicit differentiation. So this is the example between how to differentiate between explicit function and implicit function. So you can see explicit function is y in terms of x, y equals to fx. While implicit function, y we have on the left hand side and the right hand side we have xy. On the left hand side, you also have xy on the right hand side. So kalau kita tengok betul-betul ni, nak senang kenal explicit function, y sebagai subjek, belakang di sebelah kanan akan ada x. Kalau implicit function, x dan y dia bercampur. Okay. To differentiate an implicit function, write this function explicitly. To differentiate y with respect to x, we differentiate y in terms of x with respect to x, we get dy dx. To differentiate y power n with respect to x, so we differentiate y power of n with respect to x equals to differentiate y to the power of n with respect to y multiply dy dx. This is actually, we apply the chain rule. So this part, this is actually chain rule. Okay, kalau kita tengok, let's say we are going to differentiate y cube. We are going to, kita nak differentiate y cube with respect to x. We differentiate with respect to x, y cube. So first, kita akan differentiate y cube ni dulu. Differentiate y power n with respect to y. So we differentiate y cube with respect to dy, and then we multiply with dy over dx. So kat sini kita boleh notice, kat sini dy, sini pun dy. This is actually chain rule. So differentiate y cube with respect to y, we get 3y squared multiply dy dx. So senang cerita, kita cut in short, kalau nak differentiate y with respect to x. Kita differentiate y macam biasa, macam kita differentiate x, tapi kita kena tambahkan dy dx di sebelah belakang. So let's say kalau kita nak differentiate y to y, let's say. So kalau nak differentiate ni, dia akan jadi 2, differentiate 2y macam 2x, 2, kena tambah dy dx kat belakang. So ini adalah cara-cara nak differentiate y power n with respect to x. Okay, for example, we have implicit function y square plus 4x equals to 6x square. So we are going to differentiate implicitly. Okay, first you need to differentiate y square. We have y square, the first term is y square, and then we have 4x, and then we have 6x square. So kat sini, tambah kat sini, bermaksud we are going to apply some rule. So jadi, first kita differentiate y square. So it's become 2y dy dx. So kita differentiate y square, differentiate macam biasa 2y, kena tambah dy dx kat belakang. And then we differentiate 4x, we get 4. And then we differentiate 6x square, we get 12x. So kat sini kita ada 3 term lah. This is first term, second term and third term. So kita differentiate satu per satu. The first order derivative. Let's look at for example 1. Find dy dx in terms of x and y. So the question asks to find dy dx in terms of x and y. So the subject should be dy dx, and on the right hand side is suppose we have x and y term. Okay, so the first question we have implicit function y cube plus 6x equals to x squared. So this is implicit function. We are going to differentiate implicitly. So we have 3 term here. The first term is y cube, and then 6x, and then x squared. So for this case, we are going to apply some rule, since we have plus in the middle between y cube and 6x. Okay, so the first one, we differentiate y cube. So to differentiate y cube, so we differentiate y cube, we get 3y square, and then we must put dy dx at the back of 3y square. So then this is differentiate y cube, 3y square dy dx, plus, and then we differentiate 6x, we get 6, and then we differentiate x square, we get 2x. Okay, so jadi kita differentiate y cube macam kita differentiate x, tapi kita kena letak dy dx. So jadi 3y square darab dy dx, and then tambah differentiate 6x, we get 6, and then we differentiate x square, we get 2x. So jadi this is complete differentiation. Now kita nak buat dy dx sebagai subjek, dan di sebelah kanan should be ada x, ada y. So jadi kita kena pindah lah. So ni kita punya differentiate kat sini, and then kita nak simplify supaya dy dx as a subject. So then kita pindahkan 6x ke sebelah kiri. We bring 6 to the right hand side. We get 3y square dy dx equals to 2x minus 6. And then dy over dx equals to 2x minus 6 over 3y squared. So this is answer for A. And then let's look at for B. We have a B. The question B is xy, epsilon y is equal to e power to x. Okay. So this is implicit function epsilon y equals to e power to x. As you can see here, we have one term on the left hand side and one term on the right hand side. Satu-satulah, satu sebelah kiri, satu sebelah kanan. Tapi untuk sebelah kiri ni, kita ada dua benda, tetapi operasi dia adalah darab kat sini. So kalau ini, we must apply product rule. Untuk differentiate ni, kita kena apply product rule. Because this is as x darab dengan ln y. And then sebelah kanan ni, this is exponential function. So ini kita boleh direct differentiate using rule of exponential. Rule of differentiation of exponential function. So first kita kena buat product rule untuk x ln y. So let u is equal to x and v equals to ln y. So then u prime, we differentiate u prime, we get differentiate u is become u prime, differentiate x become 1. And then we differentiate v prime, and then we differentiate ln y. Macam ln x, kalau ln y dia akan dapat 1 per y, but we must put dy dx di belakang. So jadi dia akan jadi v prime equals to 1 over y dy dx. And then kita apply product rule formula, which is u v prime plus v u prime. So then x darab dengan 1 per y dy dx plus ln y darab dengan 1. So ini untuk sebelah kiri, kita differentiate sebelah kiri. And then sebelah kanan, kita nak differentiate exponent power to x. So differentiate exponent, kita salin diri dia, e power to x. And then kita differentiate power to x, power dia to x, we differentiate dia dapat 2. So darab dengan 2. So this is kita punya differentiation yang complete. This, baris ini adalah baris yang complete untuk kita differentiate lah. So jadi sekarang kita nak dapatkan dy dx. Sekarang we are going to simplify until we get dy dx as a subject. So then yang ada dy dx adalah yang ini saja. So jadi yang ni kita kekalkan di sebelah kiri. So jadi we get x over y dy dx equals to 2e to x. Sini tambah, so kalau pindah sana jadi tolak. So then minus ln y. And then to get dy dx, we divide 2e to x minus ln y divided by x over y. So then finally we get y 2e to x minus ln y over x. So this is your final answer for dy dx. So kalau ikut soalan, dia nak dy dx is in term x and y. So this is answer for question B. Let's look at for a second example involving second order derivative. Okay, the question asks to find, given that the equation of a curve is 3x squared plus 4y squared equals to 15xy minus 6. This is implicit function. Find the value of dy dx and second derivative of y with respect to x at the point 1, 3. So this is point xy. Okay, so jadi kalau kita tengok pada soalan, dia bagi satu equation of curve. Soalan dia, find the value of dy dx and d2y over dx squared at the point 1, 3. So maksudnya dia suruh cari nilai dy dx dan nilai second derivative apabila bila x sama dengan 1 dan y sama dengan 3. So jadi, apa step dia? Step dia, first, we are going to differentiate 3x squared plus 4y squared equals to 15xy minus 6. So jadi kita ada 4 term kat sini. 3x squared, 4y square, 15xy, and 6. So kita differentiate one by one. So the first one, we differentiate 3x square, we get 6x plus differentiate 4y square, we get 8y dy dx. So we must put dy dx at the back equal 15xy. This is darab x darab y. So yang ni kena apply product rule. So jadi untuk case ni for 15xy kita apply product rule. Let u equals to 15x, v equals to y. So u prime equals to 15, v prime equals to dy dx. So then kita masukkan dekat sini product rule dia 15x dy dx uv prime plus vu prime is 15 times y. So this is for differentiate 15xy. And then minus, we differentiate 6 is become 0. So tak payah tulislah. Ini boleh padam. So kita boleh padam yang tu lah. Sebab dia kosong. So finally we get complete differentiation is 6x plus 8y dy dx equals to 15x dy dx plus 15y. Okay, back to balik question. Back to the question. The question asks to find the value of dy dx at the point 1, 3. So jadi kita boleh terus ganti x1 dan y3. Tapi sebelum tu Maida nak susun dia supaya sebelah kiri Maida nak letak yang ada dy dx dan sebelah kanan nak letak yang ada y. So 8y dy dx minus 15x dy dx equals to 15y minus cx. Kita susun je balik supaya dia lebih nampak tersusun lah. Okay. So then we have 8y minus 15x dy dx equals to 15y minus 6x. Okay. So jadi sekarang kita boleh sub x equals to 1, y is equal to 3. So then 8 times 3 minus 15 times 1 dy dx equals to 15 times 3 minus 6 times 1. So then we get 24 minus 15. We get 9 dy dx equals to 45 minus 6. We get 39. So finally we get dy dx equals to 13 over 3. So this is the value of dy dx when x equals to 1, y equals to 3. So ini baru kita mencari nilai dy dx. Okay. So sekarang kita kena differentiate lagi sekali untuk dapat second derivative of y with respect to x. So jadi kita akan guna baris yang ini, baris yang terakhir sebelum kita ganti tu, which is 8y tolak 15x dy dx equals to 15y minus 6x. So kita differentiate lagi sekali. So 8y tolak 15x dy dx equals to 15y minus 6x. Ini baris terakhir yang tadi lah sebelum kita ganti value. Okay. So sekarang ni kalau kita tengok untuk yang depan ni kita ada dua term. Ni darab. Kita ada dua benda. Satu 8y tolak 15x darab dengan dy dx. Okay. So yang ni kena apply product rule. Sebab dia darab, so kena apply product rule. So untuk yang ni dia ada tolak. Jadi kita apply sum and different rule lah. Ini kita boleh differentiate one by one. So kita ada 15y, kita ada 6x. Okay. So first yang nak apply product rule ni, so kita buatlah let u equals to 8y minus 15x. So u prime equals to 8y, we differentiate, we get 8 dy dx minus 15. Then v equals to dy dx. So v prime equals to d2y over dx squared. Okay, so we substitute into formula product rule, which is uv prime plus vu prime. So 8y minus 15x multiply d2y over dx squared plus 8 dy dx minus 15 multiply dy dx equal. So then we differentiate 15y, we get 15 dy dx minus, we differentiate 6x, we get 6. So this is complete differentiation for second derivative. So jadi kita dah lengkap differentiate untuk yang kali kedua. So now kita boleh terus substitute ataupun kita nak susun-susun dia pun boleh. So katakanlah kita susun, kita letak yang second derivative sebelah kiri sebelum kita ganti. So 8y tolak 15x d2y dx square. This one kalau ikutkan kita kena expand. Kalau tak nak expand pun boleh, kita pindah je pun boleh, tak ada masalah. Okay, katakanlah kalau kita pindah terus. So, equals to 15 dy dx minus 6 minus 8 dy dx minus 15 dy dx. Okay, so then we get 15 dy dx minus 6 minus 8 dy dx square plus 15 dy dx. So this is 8y minus 15x d2y over dx square. This is actually 15x dy dx ni plus 15 dy dx, we get 30 dy dx minus 8 dy dx square minus 6. So then we can substitute x equals to 1 and y is equal to 3 and dy dx equals to 13 over 3. So kita boleh substitute tiga benda ni lah. Okay, so the first one we substitute 8y tolak 15x. So this is 8 times 3 minus 15 multiplied by 1 multiply d2y dx square equals to 30 times 13 over 3 minus 8 13 over 3 square minus 6. So then you get this is 9 d2y over dx square equals to negative 236 over 9. So finally you get d2y over dx square equals to negative 236 over 81. So this is your value of second derivative of y with respect to x. Now let's move to example 3. Given that xy equals to sin 3x, show that x d2y over dx square plus t2d dy dx plus 9xy equals to 0. So the equation asks to show this one. Okay. So kalau kita tengok dekat this equation, we have second derivative of y with respect to x and dy dx. So means that we need to find first derivative and second derivative. The given explicit function xy equals to sine 3x. Dan this kita ada dua term je, satu di sebelah kiri. We have one term on the left hand side and one term on the right hand side. Tapi untuk yang sebelah kiri, this is x multiplied by y. So suppose we need to apply product rule to differentiate. So let u is equal to x, so then v is equal to y. So u prime we get 1, v prime we get dy over dx. So then we apply product rule formula. So we get u v prime, which is x dy dx, plus vu prime, we get y times dengan 1. And then on the right hand side, we have sine 3x. So this is differentiation of trigo. So differentiate sine, we get cos. So suppose sine 3x, we get cos 3x. And then we need to differentiate angle, which is 3x. So we get 3. So this is multiplied by 3. So finally we get complete differentiation here. First derivative, x dy dx plus y equals to 3 cos 3x. So ini baru first derivative. So then second derivative, kita kena differentiate lagi sekali. So since kita punya implicit function untuk first derivative ni, kita ada 3 term. Ini first term dia, ini second term and third term. Okay. So yang ini kalau kita tengok, we suppose kena apply product rule. X dy dx, x multiplied by dy dx. And then y kita boleh direct differentiate, and on the right hand side we have 3 cos 3x. So this is supposed differentiate trigo untuk cos. Okay. So untuk x dy dx, so let u equals to x, v equals to dy dx. So then we get we need to differentiate u and v. So u prime is 1, v prime is differentiate dy dx, we get second derivative of y with respect to x. So then we apply formula product rule u v prime, which is x d2y over dx square plus dy dx multiplied by 1. So kita tulis dy dx saja. And then we differentiate y plus dy dx equals to, we differentiate 3 cos 3x, 3 salin, we copy 3, and then we differentiate cos 3x, we get negative sine 3x, and then we differentiate 3x, we get 3. So finally we get negative 9 sine 3x. So complete kita punya second derivative kita, x d2y over dx square plus 2 dy dx. So yang ini kita boleh tambah, equals to negative 9 sine 3x. So then back to question. Kita punya question, kita nak show x second derivative of y plus 2 dy dx plus 9x square equals to 0. So jadi kita dah ada, untuk yang depan kita dah ada. Okay, and then sebelah kanan kita mesti dapat equals to 0. So jadi yang ini kita bawa ke sebelah kiri. So x d2y over dx square plus 2 dy dx plus 9 sin 3x. Kalau tengok kat sini, kita nak dapat dekat 9 sin 3x ni, suppose kita kena dapat 9xy. Since ini back to balik kita punya implicit function yang original, xy is equal to sin 3x. So finally we get yang ini kita ganti dengan xy. So finally we get x second derivative of y with respect to x plus 2 dy dx plus 9 xy is equal to 0. So jadi kita dah dapat shun. Now we continue with example 4. The curve x cubed plus y cubed equals to kx plus 2y. So this is implicit function. And the curve passes through point 1, negative 1, 1. So means that point 1, 1, negative 1 is on the curve. So then we can substitute 1, x equals to 1, y equals to negative 1 into equation. So jadi kita boleh substitute x sama dengan 1, y sama dengan negatif 1 ke dalam equation ni. Determine the value of the constant k and show that 3y square minus 2 multiply second derivative of y with respect to x plus 6y dy dx square plus 6x equals to 0. So we have two objectives for this question. First, we are going to find constant k. So jadi clearly untuk cari constant k, kita boleh substitute teruslah 0.11 1 negative 1 into x cube plus y cube equals to kx plus 2y. So first equation, we sub x equals to 1, y equals to negative 1 into x cube plus y cube equals to kx plus 2y. So then we get 1 cube plus negative 1 cube equals to k times 1 plus 2 times negative 1. So this is become 1 cube is 1, negative 1 cube is negative 1. So then it's become 0 equals to k minus 2. So finally we get k is equal to 2. So the constant k, suppose k equals to 2. So then for question B, we are going to show this equation. So kalau kita tengok pada this equation, if we observe this equation, we have second derivative and first derivative. So means that we need to differentiate 2 times. So kita kena differentiate 2 kali lah untuk cari dy dx, lepas tu cari second derivative of y with respect to x. So jadi first kita kena cari dulu dy dx. So jadi since kita dah dapat k, so jadi equation kita x cube plus y cube equals to 2x plus 2y. Okay. So kita ada 4 term kat sini. The first term, second term, third term and fourth term. Okay. Yang first term kita differentiate, we get x cube. Kalau kita differentiate, we get 3x square. Plus, and then we differentiate y cube, we get 3y square dy dx equals to, differentiate 2x, we get 2 plus, we differentiate 2y, we get 2 dy dx. So jadi this is complete differentiation for first derivative. So then kalau nak senangkan awak susun supaya yang sebelah kiri kita letak yang dy dx. So jadi 3y square dy dx ini kita kekalkan, and then kita pindah 2 dy dx is minus 2 dy dx equals to 2. And then kita pindah ke sini, we get minus 3x square. So then 3y square minus 2 dy dx equals to 2 minus 3x square. Okay. Then kita boleh differentiate lagi sekali. Okay. Kalau kita tengok sini, sini kita ada satu term. Sebelah kiri kita ada satu term. Kita ada 2 term di sebelah kanan sebab ni tolak ya. Ni darab. Yang depan ni darab. Darab kita anggap dia satu. Ni ada 2 term. Sebab kalau tolak ataupun tambah, kita boleh differentiate 1 by 1. So yang ni kita kena apply. Untuk yang sebelah kiri kita apply product rule. Dia darab. Yang sebelah kanan kita differentiate 1 by 1. Differentiate 2 and then we differentiate 3x square. Okay. So let u is equals to 3y square minus 2, then v equals to dy dx. Okay. U prime we get 6y dy dx Differentiate 2 is become 0. So jadi u prime is 6y dy dx. V prime we get second derivative of y with respect to x. So then kita boleh apply formula uv prime plus vu prime. So 3y square minus 2 times second derivative of y with respect to x plus 6y dy dx square. Okay. Ini untuk sebelah kiri. And then sebelah kanan, we differentiate 2, we get 0. Kita tulis 0 minus, we differentiate 3x square become 6x. So untuk sebelah kiri kita dapat, sebelah kanan kita dapat tolak 6x. Okay. So then back to balik pada kita punya yang kita nak show. Suppose kat depan ni kita ada 3y square minus 2 second derivative of y with respect to x. Plus 6y dy dx square plus 6x equals to 0. So jadi ni semua kita dah dapat. Just kita kena pindahkan 6 minus 6x ni ke sebelah kiri supaya sebelah kanan jadi kosong. So finally 3y square minus 2 d2y dx square plus 6y dy dx square plus 6x equals to 0. So kita dapat shown. Okay, so this is example. Finally, let's look at for exercise. We have question find dy dx in term of x and y. So soalan tanya dia nak dy dx in term of x and y. So given implicit function 3y square plus 2y equals to xy, sorry, 3y square plus 2y plus xy equals to x cube. So jadi kita ada empat term ni. Ni first term, second term, third term and fourth term. Okay, first term ni boleh direct differentiate, we get 6y dy dx. Second term we get 2 dy dx. But third term we need to apply product rule. Since x darab dengan y, ini darab y ya. So jadi kita kena apply product rule. So u, let u equals to x, v equals to y. So u prime equals to 1, v prime equals to dy dx. So then plus x dy dx plus y multiplied by 1 and then equals to 3x square. So yang ni kita differentiate x cube, we get 3x square. So ni dah complete kita punya differentiation. Ni differentiation kita dah complete lah. So then we need to simplify until we get dy dx as a subject. Sampai kita dapat dy dx lah. Okay. So jadi kita boleh pindah dulu y ni ke sebelah kanan. So we get 6y dy dx plus 2 dy dx plus x dy dx equals to 3x square minus y. And then kita nak dy dx sebagai subjek. So kalau tengok kat sini, yang sebelah kiri kita ada 6y dy dx plus 2 dy dx plus x dy dx. So jadi kita boleh factor dy dx. Kita factorkan dy dx. So then we get dy dx yang tinggal 6y plus 2 plus x equals to 3x square minus y. So then finally our dy dx is 3x square minus y over 6y plus 2 plus x. So this is your final answer. So this is lecture 4 of 5. So then next we continue with lecture 5 of 5, which is involving parametric differentiation. That's all for now. Thank you. Assalamualaikum. Bye.